recording. This is what we are going to look for it. And for these starting points, I'm going to give you 3 types of these functions, and we will try to build on that. You already know some of these facts. First thing is when you have limit of 1 over x, this could go either to plus infinity or minus infinity. Do you remember the graph of 1 over x? Yeah? As x goes to infinity, values of the function approaches to 0. Either to plus infinity or negative infinity. So I will accept from you whenever you get across such limit, you just write 0, because that's something you know. What more is this? If this is x to the power r is a positive number, that is still true. As x goes to plus infinity or minus infinity, 1 over x to the power some number is going to go to 0. The second thing is limit of b to the power x. We know that b to the power x, remember the graphs of b to the power x? It is either going this way if b is bigger than 1, or it is going this way if b is less than 1, obviously bigger than 0. Now, just by knowing the graph of exponential function, this is another piece of information I will accept from you. That b to the power x, as x goes to negative infinity, is 0 if b is bigger than 1. And the other way around, if x goes to plus infinity, b to the power x is 0. When b is less than 1, 0. Make sure that you're noticing this is going to negative infinity, this is going to plus infinity. Yeah? One more thing that you know it based on the graph. Let me ask you, do you know any other function that we studied recently which has limit at infinity? Nice one. Does anyone remember anything that based on the graph we can write things? Well, then I will do it myself. You don't answer, I will answer that. Tan inverse x. Remember the graph of tan inverse? Do you remember it? Do you remember it or no? No. Go home, find it, remember it. This is y equal to pi over 2. This is negative pi over 2. It goes like that. As x goes to plus infinity, this limit is pi over 2. As x goes to negative infinity, this is equal to negative pi over 2. As the facts, basic facts, knowing the graph of these functions, I will accept any of these 3 things. You write, I will accept it without any explanation. Limit of tan inverse as x goes to plus infinity is pi over 2. I will accept that. No explanation is needed. Now, I want to create these tools. I want to make sure that we have enough tools to calculate limits at infinity. One basic tool, this is, I'll write it as theorem, says that limit at infinities you can turn into regular limits. And this is very interesting, nice fact. It says that limit of f of x as x approaches to plus infinity, you can turn it to a limit of something going to 0 from the right-hand side. This is kind of change of variable for limits, which you turn x limit into t limit. But each x you see in the formula of your function, you replace it by 1 over t. 1 over t. Change x's to 1 over t, your limit at infinity will become limit as x approaches to 0 from right, if it is limit going to the x plus infinity, or if it is from the negative infinity, it will turn to 0 minus of this. This is a fact, fundamental fact. Calculationally, well, why not I use an example here? I can use one example here so that it shows how this will work. Example, find limit of e to the power 1 over x, x approaching to plus infinity, or this other one, x plus 1, 3x minus 2 as x approaches to negative infinity. Before I give you the time for you to start working on those ones, the key point for me here for those examples is that I can turn limit at infinity to one-sided limits at 0. How? By replacing x by 1 over t. So go ahead. You may know other methods of calculating those limits, but my hope is that you're trying to use those tools before I say what is important result of that tool. Okay? Go ahead. 1 minute is more than enough for those two examples. You can talk to a person sitting next to you if you feel you need some discussion. Go ahead, please. If you cannot do it, talk to a person sitting next to you. Try to focus on the example. Okay. Turn infinite limit at infinity to limit at 0. There's one. I need to use a different variable. X goes to infinity. I will use t goes to 0 plus f instead of x, wherever I see x, I plug in 1 over t. What else you need there? This is now regular limit. If you have learned the regular limits, now it's the time to use it, yes? And in this case, exponential function is continuous, means that I can just plug in and I get the value 1. Yeah? For the second one, yes, okay. So this is limit of 1 over t plus 1, 3 times 1 over t minus 2, t goes to 0 from the left, yeah? And then simplify this. Like that, yes? And we are approaching to 0. We don't have 0. I can cancel these two guys. And then get limit of 1 plus t over 3 minus 2t. T approaches to 0 from negative side. Yes, and this is one of those easy limits. Quotient law or direct substitution for the rational functions will give me the final answer. I'm writing this up here. 1 plus 0, 3 minus 2 times 0, which is 1 over 3. Yes, please.
Usually plug in 1 over t into x, not just over there substitute t equals 0.
Limit, substitution are two different things. I didn't say you just substitute t equal to 0. I said I turn your limit to another limit. Now, when I give you a limit, are you allowed to just go ahead and substitute the things into that? It is possible in some cases, but not always, yes? So this fact is saying that some limits can be turned, limit at infinity can be turned into regular one-sided limits. Yeah? Is that good? Any other questions? Well, calculationally, you will notice more and more, this guy is going to do good for us, but it's not going to go much when it comes to do more examples. However, since this says that limit at infinity in some ways is like regular limit, then we should be able to go ahead and use the tools that are available for the regular limit for the limit at infinity. In other words, as a result, we have this first tool, calculational tool, or maybe the second calculational tool. All limit laws work for limit at infinity. If you know sum of two functions, limit of each one, you can find limit at infinity of each one, add them. Subtract them if it is subtraction. Multiply them if it is multiplication, and so on. Yes? So limit laws now are good when x approaches to plus infinity or minus infinity. What is other tool? What is other calculational tool that we have for limits? We have one limit laws. What else we know about? Yes?
IBT and squeeze theorem.
IBT is for continuous function. Yes, it is a bit further. But squeeze theorem is the other tool we have. So now squeeze theorem will work for limit at infinity. So the squeeze theorem is still, okay, it's good, back to the work. Let me write, for example, what does it mean, squeeze theorem, when x approaches to infinity? Remember, for squeeze theorem, we have these two functions which are bounding our original function. When we are looking for squeeze theorem at plus infinity, this equality should be true after one point. After some point, these two functions should be bounding our original function. And if limit of the lower one as x approaches to plus infinity is equal to limit of upper one as x approaches to plus infinity, they both exist and is equal to L, then squeeze theorem will tell me that limit of the middle function as x goes to plus infinity is equal to L as well. All these 15 minutes of work, what I wanted to tell you is this, that the old tools that we had still will work here for limit at infinity. And let's do some examples. And maybe before I do write the examples, any questions, any comments? OK. How about try to evaluate this limit. As x goes to plus infinity. How about limit of sine x over x as x goes to plus infinity? Doesn't matter. 90 seconds? Do you think it's good? Yeah? No?
Which one again?
For both of them. Okay, so I'm hoping that in 1 minute you at least get down the right ideas for this one, and then think about how this specific one is going to be able to, this you can evaluate it using squeeze theorem. 90 seconds. If you cannot do it, start talking to a friend sitting next to you. Step by step. Focus on one example. See what are there, what you want to do, and how you can proceed only one next step. 90 seconds. Okay. Look at this thing. If I know limit of this one and limit of this one, if I know limit of this one as x approaches to infinity, limit of tan inverse x as x approaches to plus infinity. And then if I know limit of 3 to the power negative x plus 2 as x approaches to plus infinity, if both of them are numbers, then I can use the product law and multiply them, yes? That's what limit law says. Here, what is limit of tan inverse as x approaches to plus infinity?
Pi over 2.
Pi over 2. The graph is still over there. So this guy, yes, we know it is pi over 2. How about limit of 3 to the power negative x as x goes to, forget plus 2 for the moment, yes? What is limit of 3 to the power negative x?
3 to the power of negative x has a limit of 0. Add to it, the limit goes to
Plus 2. How did you get this as 0? How did you get this as 0?
It'll be like 3 over an ever-increasing number.
Can you say it based on b to the power x? You remember that we had this b to the power x's. If x is bigger than 1, it will work, and for less than 1. Yes. Sorry? Why it is between 0 and 1?
It's not. Never mind. I said the wrong thing.
Okay. Anyone else? Can I hear the answer for that based on b to the power x? Yes, please.
It's like 1 over x to the power of r. So because of that, it would equal to 0.
Sorry. You're saying that it is like 1 over x to the power r. This is 3 to the power x.
Yeah, but if you reduce it to 3 to the power.
I see. Okay. So you're seeing the right point. Maybe the way you said is not. Look at this. This is another b to the power x. 3 to the power negative x, as your friend said, is 1 over 3 to the power x. Yes? As limit of x goes to plus infinity, plus 2. Now, b to the power x. If b is less than 1 and x goes to plus infinity, will give you limit 0, and that is 0 plus 2. What did I use here? This is sum law. And then that part is there. Now that I know both of them exist, product law will say the first one has limit 2, the second one has limit pi over 2. So the limit is pi. Okay. Any questions, any comments there? Yes, please. Yes. Oh, you're good? Okay. Okay, let's think about the second one. One thing that before we start doing it, when x goes to 0, sine that's why I ask if you have questions, you can ask me. They're busy still. It's good that you're talking, but there is a reason I'm asking. You can ask your questions so that we can move on to the next one. Do you have questions you do want to ask now, or we can talk at the end if you don't feel like? Okay. What is the value of this limit? Sine x over x as x goes to 0. 1. Well, proof of this needs a little bit of work. I posted the video. Hopefully, you will watch it somewhere. This limit is not the same limit. This is sine x over x as x approaches to plus infinity. So we have to be careful. This is not, we cannot use that fact and say this is 1. However, I can say that sine x is always between 1 and negative 1. For all x's, for all x's bigger than 0, I can multiply 1 over x to 3 sides of this. So I get this, that, that. Now, for all x's bigger than 0, I have my function sine x over x bounded by negative 1 over x, positive 1 over x. What is limit of negative 1 over x as x approaches to plus infinity? What is limit of 1 over x as x approaches to plus infinity? 0. Louder. 0. Louder. 0. What is limit of 1 over x as x approaches to plus infinity?
0.
What did happen? 0. Yes? So the function for all x's bigger than 0 is between these two functions. Upper one and the lower one has the same limit. That means that squeeze theorem can be applied, and we get limit of middle one as x approaches to plus infinity is equal to 0. Just enough of tools that we can start working with these infinite limits. Any questions, any comments before? Yes, please. So I know that sine x over x, sine x is always between 1 and negative 1, yes? Now, if x is bigger than 0, 1 over x is going to be bigger than 0. I multiply all sides of this inequality by 1 over x. Negative 1 times 1 over x is this. Sine x times 1 over x is that, and so on. Yeah, thanks. Any other question, any other comments? Now, I want to make one definition you probably already know. It is about, again, the same story, just there's a terminology you have to know. we say the horizontal line y equal to L is a horizontal asymptote for f if either the right limit of that function as x approaches, sorry, not right limit, as x approaches to plus infinity, that function gives you L, or from when x approaches to negative infinity, it gives you L. One thing important here is that, well, we already know some examples. For example, now we know that sine x y equal to 0 is a horizontal, let me write HA for sine x over x. Why? Because we found limit of this function as x approaches to plus infinity, and we got 0. If you do the negative infinity, you also get the same thing. So it has just one horizontal asymptote. This guy has y equal to pi is a horizontal asymptote for this guy. Why? Because when x goes to plus infinity, it is, the limit is equal to pi. Yeah? Tan x has two horizontal asymptotes. When x approaching to plus infinity, it gives me pi over 2. When x approaches to negative infinity, it gives me negative pi over 2. So y equal to pi over 2 and y equal to negative pi over 2 are horizontal asymptotes of tan inverse x. Whenever someone's asking you to find horizontal asymptotes, you have two limits to consider. You try to find limit of function as x approaches to plus infinity and as x approaches to negative infinity. Any of them gives you a number, y equal to that number is a horizontal asymptote. At most, a function can have two horizontal asymptotes, because one you can get from the positive side, one you can get from the negative side. That's a terminology that I'll come back to this, but I want to go over one more thing, which is, I'll do this example. I'll do this example, and through that, I'll show you how this works. The tools, remember that we almost have only two tools here. The rest is basically the same things, yes? Now, I look at this thing, and I see, oh, x plus 1. What happens to x plus 1 as x approaches to plus infinity? X plus 1, as x approaches to plus infinity, what happens? Yes? Or other way of saying this is that if x is growing big and big and big and big, you add 1, still it's growing big and big and big. The same argument is here. X is going to plus infinity, 3 times big and big and big number is big and big and big number. You take away 2, still it is big and big and big and big number, yes? Yes? So you charge Elon Musk $10, still he's a billionaire. $2, it's still a billionaire, yes? That's the same story. So you see that this, I cannot use limit laws because it's not giving me numbers. It's giving me infinity over infinity. Does that remind you of something? Yes? 0 over 0 indeterminate form. There is another indeterminate form called infinity over infinity. And well, there are a bunch of other indeterminate forms. We will get back to it and we will study later on. But for now, I want to focus on this specific one. How do we solve this kind of things? If it is a polynomial over polynomial, what did we do when we had 0 over 0?
Cancel.
Factor, cancel. The same story will work here. However, what I'm going to cancel is not x minus infinity. It doesn't make sense. I'll factor highest power from the numerator and highest power from the denominator out. Wait a minute. This doesn't have any x in it. By factoring here, I mean you can divide each term by x. See, if I multiply x back in, I get x plus x times 1 over x, which is 1, x plus 1. Here, I factored out 3 minus 2 over x. And x goes to plus infinity. So I factored highest power. Now I want to cancel. These are the factors that send things to infinity. I'm canceling those ones. And I'm getting a new limit. As x goes to plus infinity. Now, my claim is that by this point, you should be able to see, if it is polynomial over another polynomial, you should be able to see that, oh, this is easy. Why? I can apply quotient law, limit of numerator. Limit of 1 as x approaches to infinity is 1. Limit of 1 over x as x approaches to infinity is 0. Limit of 3 as x approaches to infinity is 3. And limit of 2 over x as x approaches to infinity is? We again did the same story. We factored, we canceled. But when it comes to infinity, you have to be a little bit more careful and then factor out the highest power. Can anyone see why am I factoring out highest power of that polynomial? Yes, please.
Get rid of the factor that makes it become indeterminate?
That's, in some ways, that's right, yes. So to get the highest power is the thing that makes it infinity. So we want to get rid of it. But there is also another easier way to see it. When you factor out the highest power, all the other powers as x, because the other powers are less than that, you will get 1 over some power of x. And that thing will go to 0. That thing will go to 0. So they will disappear. The lower terms, in some ways, will disappear. Let's do these two examples. And then, OK, I'll write one here. How about you try to tell me what is limit of x squared plus x plus 1 over x cubed plus 3x squared minus 1 as x approaches to plus infinity. Also, limit of 2 to the power x plus 3 to the power x over 4 to the power x minus 2 to the power x as x approaches to plus infinity. Go ahead, please. I will give you 2 minutes. Wow, so much time. So keep in mind, I know some of you, or most of you, had some trick from high school which makes things easier. But now the question is not what is the final answer. The question is, how to write down things. Try to work on that, similar to the example that I presented there. You first notice that it is an indeterminate form, and then try to get rid of that indeterminate form by factoring highest powers, and then resolve it to the thing that you're looking for. Go ahead, please. You have 2 minutes. You're either working on that yourself or you're talking to someone and trying to come up with ideas. You have 50 seconds left. Okay, let's see. Go slowly as x approaches to infinity. When you look at a polynomial, if it is approaching to plus infinity, polynomials always go to infinity. So this guy is plus infinity over plus infinity. Infinity over infinity. When it is polynomial over polynomial, you resolve it by factoring out highest power of the numerator and highest power of the denominator. So in this case, I get 1 here. X over x squared is 1 over x. This guy is 1 over x squared. This guy here, 1 plus 3 over x minus 1 over x cubed. And x goes to plus infinity. Factor and then cancel. So I'm canceling this with that. Well, there's an x left there. Now, the remaining part, I can separate it and use product law and say, okay, this is limit of 1 over x, this part, times limit of 1 plus 1 over x plus 1 over x squared over 1 plus 3x minus 1 over x cubed, as x approaches to plus infinity. Limit of 1 over x as x approaches to plus infinity is 0. Limit of this guy. So I can use the quotient rule, go to the numerator. This goes to 0, this goes to 0, this goes to 0, this goes to 0. So I get, yes, please.
Also factor out x to the power of 2.
You could do that as well. However, yes, in this case, this will work. But in general, you have to be careful, okay? Yes, in this case, this will be 1 plus 0 over 1 plus 0 plus 0, which is 0 times 1, it is 0. Let's do this one. Exponential functions. X goes to infinity. This guy, both of them grow to infinity. This goes to infinity. This also goes to infinity. But this goes way faster to infinity. So it is infinity over infinity. Now, I want to resolve it. What should I factor out here? What should I factor out here? 3x. Why 3x? This is not power, this is exponent. But if we change that highest power to dominant term, when you're working with the polynomials, x goes to infinity or negative infinity, the highest power is the dominant term. It is the term that grows the fastest, yes? Here now you can say, I want to factor the dominant factor, which means the exponential with the largest basis. So it will be 3 to the power x, 2x over 3x plus 1. Here I factor 4 to the power x, 1 minus 2 over x over 4 to the power x. Yeah? Now, look carefully how I'm going to handle this. I'm separating this piece here. 3 to the power x over 4 to the power x is going to give me 3 over 4 to the power x as x approaches to plus infinity. The other one, this is 2 over 3 to the power x plus 1. This guy here is 2 over 4 to the power x. X goes to plus infinity. Why are you simplifying all those things to that format? Because I want to have all to the b to the power x's in all these cases. Now, if b is less than 1, x goes to plus infinity, 3 over 4 to the power as it goes to infinity, what would I get here? 0. Let's see what I will get here. This, again, is less than 1 to the power x. I get 0 plus 1. This is, again, so dominant term in the polynomial is the highest power. When x goes to infinity for the exponential ones, it is the highest base. For when x goes to negative infinity, it is the lowest base. Lowest base in that case. Any questions? Any comments? I need to do one clicker question. So I will, sorry, I did that. Hello, hello. The camera is not picking me, right? Please, hello, come, okay. Go ahead. You have 2 minutes on that. How many horizontal asymptotes we have for that function? Go ahead, please. The question is over there. You are trying to see what are the limits as x goes to plus infinity and minus infinity. Let's at least do one of them. As x goes to negative infinity, as x goes to negative infinity, what is limit of e to the power x? What is limit of e to the power x as x goes to negative infinity? 0. Plus 1, that's 1. There is also 0 here, minus 2. I can apply quotient law here. And it's 0 plus 1 over 3 times 0 minus 2, which is negative 1 over 2. So at least we have one asymptote. We cannot have 3 horizontal asymptotes, by the way. There's only 2 limits, either that way or that way. Now, for this one, as x goes to infinity, e to the power x goes to no infinity. E to the power x, x goes to infinity. So we have infinity over, you factor out the dominant term, yes? Dominant term in this case is e to the power x. I factor out, I cancel. Now, 1 over e to the power x is the same thing as 1 over e to the power x, yes? E is bigger than 1. 1 over e is going to be less than 1. As x goes to infinity, b to the power x, if b is less than 1, as x goes to infinity, it will go to 0. So this will go to 0. This will go to 0. I get 1 plus 0 over 3 minus 0. Y equal to negative half is a horizontal asymptote. Y equal to 1 over 3 is another horizontal asymptote. Have a great day. On Monday is the reconciliation day. We won't have any class. We will start everything on Wednesday.